relating this absolute value function to a piecewise function, whereas the composition of two linear functions is a little bit new, so we maybe want to try to relate it to something we already know. And let's maybe think of maybe a parabola. And if I were to graph x minus 4 squared minus 3, we could find the vertex of that parabola, or the center, at 4, negative 3. Okay, so that would be the vertex. Let's take a look what happens when we graph this function. Okay, and again, we have to keep in mind that, remember, there's a boundary here at x equals 4, and something is going to bend the graph at x equals 4. So let's take a look at that. So what's the coordinate where the graph bends? Okay, the graph bends at x equals 4. This is my boundary. Okay, that's where the graph is going to bend. And when I graph at x equals 4, y will equal negative 3. So at 4, negative 3, there is my bend point. In fact, we know that by looking at the previous graphs, the bend point is essentially the vertex. It's also the symmetry point of a absolute value function. This happens to be the vertex as well. Okay, and I can plot my table of values just to make sure. X, y, I know my boundary points 4 and negative 3. Okay, and if I go to the left, for example, 3 becomes negative 1 absolute value, minus 3 is negative 2. Let's maybe go 0. Okay, 0 minus 4 is negative 4. Positive 4 minus 3 is going to be 1. And I'll do some symmetrical points over here, so I'm just going to draw that in. Okay, 3, negative 2 is right there. Did I do that correctly? I think 3, negative 2. Yeah, this point's incorrect. That point there is at 4, negative 3. There we are. Okay, so those are those 2 points. Okay, maybe I'll just write them a little bit more clearly. Okay, so negative 2 at 5. 5 minus 4, well, it doesn't do anything. So just 5 minus 4 minus 3 is going to be negative 2. Okay, and let's go to positive 8. 8 minus 4 is 1. Absolute value doesn't do anything. Minus 3 is positive 1. So 5, 6, 7, 8. There it is. So there is my absolute value function. And in fact, that red dot does represent the vertex of that function. Okay, so the vertex of this function is at 4, and negative 3. In fact, the vertex, if we can imagine, this is actually very similar to, in fact, it's essentially the same as when we had y equals x minus 4 squared minus 3. In the parabola form, the vertex is also located by those 2 coordinates. Okay, so this is my vertex here of the parabola. So I want you to make the connection. There is a reason why it's doing this, is because of how we're going to start looking at things in grade 12 in terms of function. As a function, we can establish key parts of functions by some parts of the equation. So the vertex of this function is where the graph changes direction, and that's going to be the domain restriction, okay, where the boundary is, okay, where my domain is on one side of 4 versus the other side of 4. It's the domain of the piecewise function. Okay, and can we make connections for the absolute value graph and the graph of the parabola? Yeah, I think we can. This is what we did here. This expression and this expression are very similar. So we can say that the vertex of the absolute value function shows up in the equation the same as it does in the parabola. Okay, so this is a connection we want to make, because, and this is a big idea connection, because you'll start seeing this more and more prevalently. But again, if we take a look at this equation, the vertex of this equation is going to be at 3, negative 4, negative 3. Similarly, that's how we found the vertex of a parabola.